Hey everybody. In this little video we're going to be talking about Python variables and how they actually work. Now if you've got any prior programming experience, someone may have told you that a variable acts like a little box that holds data. Well, that's true for some other languages, but it's really not the way Python works. So we're gonna explore what variables are, how they work, and in particular, we're going to talk about what happens when you call a function, especially a function that has a default parameter. This is an aspect of Python that can be very confusing if your conception of how a variable works is based on something that you've learned about other languages. Okay, so the screen I'm looking at right now is a page from the official Python language reference document. This is a very technical document. It's really written for programmers and language designers and people who really want to dive deep into how Python actually works under the covers. Um, Section 4.2 is what we're going to be looking at, naming and binding. I'm going to use those terms quite a bit during this video. Names, objects, and bindings. All right, and that's really the key to what's going on with Python variables. Um, let's look at this first sentence here. It says names refer to objects and names are introduced by name binding operations. The next paragraph is very technical. It's very dense. There's a lot of information. You really have to read this word by word and really think about what it says to get the full meaning of what's going on here. And I just want to concentrate on two parts of this description. Okay, it says the following constructs bind names. So these are all the different ways that name binding can happen in your program. Um, Formal parameters to functions. That's one thing we're going to talk about. And targets that are identifiers if occurring in an assignment. So that's really talking about assignment statements. So functions, function calls, assignment statements. Those are the things we're really going to be focusing on. Okay. I'm going to switch to a different screen here. This is the famous Python tutor website. It's a great tool for experimenting with code, visualizing it, and really understanding what's happening under the covers. So the first thing I want to do is write a little bit of code that does a simple variable assignment. All right, so I'm going to say x equals 42. So I have a variable named x, I have a value of 42, and I have the equal sign, which is doing the assignment. Let's be more specific and more correct in our terminology. Okay. The thing on the right-hand side of the equal sign, that's an object. Everything in Python is an object, even simple things like numbers. Those are actually objects. They're complete objects. They have methods, they have identities, they inherit from other classes, everything you would expect an object to do. And on the left-hand side, we have the variable. This is not a little box that contains data. In fact, in Python, variables don't really contain anything. They're actually not even objects. It's best to think of them as names or labels that are attached or as the documentation says, bound to objects. So this is a name binding. We're binding the name of X to the object integer 42. All right. Now I've got some options here on how I can display the results when I run this code. I'm going to say render all objects on the heap. That's going to give me a very detailed picture of what's going on. And I'm going to say hide exited frames because I don't want to clutter up my diagram with things that are not relevant. And we're going to draw pointers as arrows. Let's go ahead and run this and see what it does. We're going to visualize the execution. Here's our code. It's just one line of code. I can run this by clicking the forward button. And here's a graphic description of what just happened. Okay. I created a name called X. I created an integer object with a value of 42, and I created a binding between the name and the object. This is key. Okay. The object is not stored inside the variable. The object actually exists somewhere out in memory in what we normally refer to as the heap, which is just free memory that Python can use to create new objects. All right. Now, let's stop this and do something a little different. I'm going to create a list. 1, 2, 3, a list of 3 integers. And the same thing is going to happen when I run this code. I'm going to bind this name X to the list. Let's see what that looks like. All right, there's a lot going on here. Let me zoom in so we can really see what's happening. I have my variable X. What is it bound to? It's bound to a list object. Now the list object contains some additional bindings. Each position in the list binds to an integer object. Again, the objects are not stored inside the list. The only thing the list contains is bindings, or what we would call references, to objects that are actually somewhere out in memory outside the list. All right. So this brings up an interesting point. There are actually 2 ways you can bind objects. You can bind by name, which is what we do when we create a variable. You can also bind things by position, which is what happens when you create a list. Right? These integers are not bound to named variables. They're just bound to positions inside this list object. So that's another thing to keep in mind. A binding doesn't have to be to a name. It can actually be to a position inside some other object. All right, moving forward. Let's talk about functions and parameters and what happens when you call a function and pass an actual argument to the function. I'm going to define a function. I'm going to call it my function. I'm going to give it one parameter. I'm going to call it X. I'm going to write pass because I don't really care about doing anything inside this function. I just want the definition of the function. Let's run this code and see what happens. All right, this red arrow indicates the line of code that's just about to be executed. So I'm just about to define the function. If I click forward, that completes running the definition. Let's look at what we have here. We have a binding to what is actually the name of the function. Right? So we're binding a function object to this name. Right? So in some sense, the name of the function acts like a variable to some degree. And again, we've got the name, we have the object over here, and we have the binding from the name to the object. Remember, everything in Python is an object. Functions are objects too, right? So now let's call the function. And what I'm going to do is I'm going to call this function with a value of, let's say, 42. Right? Let's run that. The first thing that happens is we define the function. Notice the red arrow. We're just getting ready now to make this call. All right. I step into the code. Notice the red arrow. I'm just getting ready to enter the function, right? But the call has already been set up, right? I've already taken the parameter of the function, this x parameter, and I've already bound it to the value that I'm passing in. So at this point, we have a valid binding from the parameter to an object. And then, of course, we run this and it steps into the function. We're going to just execute a pass instruction, which doesn't do anything. We've set up a return value from the function. Every function in Python has to return something. If you don't tell it what to return, it's going to default to returning a value of none. And we are now finished. That's it. The code has run. We've called the function. We've returned, and we're done. So there's an example of how an object gets bound to a function parameter. Now we're going to do something a little bit tricky. We're going to define a default value for this parameter. The way you do that is with an equal sign. So I'm going to say x equals 99 and give it a different number. Okay. So I'm creating a binding from the parameter to this integer 99. Let's watch what happens. I'm going to define the function. Now let's stop for a second. This definition looks a lot different than what we had before. We still have the name of the function. We still have a function object, but now we have this new thing. We have this default argument where we've bound x to the default object, which in this case is an integer with a value of 99. I want to point out that we've not actually run the function yet. All we've done is define it. So this default is actually being stored as part of the definition of the function. And this only happens once when the function gets defined. It's also important to notice that this default value, because it's stored as part of the definition, it retains its value between function calls. If you've used some other languages like C or C++ or Java, you might be familiar with the idea of a static variable, which is a variable that you can define inside a function that retains its value between function calls. This acts in a similar way. It's not exactly the same idea, but it still has the effect of retaining the value from one function call to the next. All right, the next thing we're going to do is call the function. Again, I've given it a value of 42 as an actual parameter. So when I set up the function call, my parameter x gets bound to 42. And again, we step into the function, we execute the pass command, we return a value of none, and we're finished. Now let's look at what happens if we don't pass in a value. I'm going to just call this function without giving it any parameters at all. Okay, we're going to run the code again. The definition looks the same. Nothing there has changed. I still have my function name, my default argument, my default object, my default binding. Okay. Now when I call the function, because I didn't give a parameter, the setup of the function is going to be a little bit different. I didn't give a parameter, so Python has to use the default binding for that parameter. So now the parameter is set up to point to the default object, which is stored inside the function. I can step into the function, I can execute the pass command, I get the same return value of none, everything's fine. So I hope you're starting to get a sense for how these bindings work and what the effect is when your code actually runs. The next thing we're going to do is talk about a mutable default binding. Up to this point, I've only used integers. There's not a lot you can do to damage the value of an integer. The integers are immutable. That means they can't be changed. Right? But now I'm going to do something different. I'm going to give a default value of an empty list. Okay? And I'm going to change the function. I'm going to change the function to actually do something with that list. So I'm going to say x append I am a list. There, just to be different. I'm going to get rid of the pass. I don't really need that anymore. Let's call this with a parameter. Right? I'm going to pass in an actual list, and I'm going to put a string inside the list. I'm going to say hello. So I'm going to pass in this list, and it's going to append a value to the list. Let's run this. I'm going to define the function. Now in this case, my default binding is binding to an empty list. All right, now we're going to run the function. We're going to call the function. I gave an actual parameter, so the parameter x is binding to a list, which contains a binding to a string. I got two bindings happening here, a binding to the list, and then inside the list, another binding to the string. I'm going to execute the append command, and I've created a second binding inside the list. So every time you append to a list, you create a new binding to a new object. So now the list contains hello, I am a list. We've set up the return value to be none, and we just exit the function. Everything's fine. Notice our default binding is to an empty list, and after the function executes, the list is still empty. Now, here's where things can really go haywire. I'm going to call the function, but this time I'm going to force it to use the default binding. Okay, I've defined the function. There's the name, there's the parameter x, there's the binding to an empty list. I'm going to get ready to call the function. Now in this case, my parameter x is binding to my default object because I didn't give a parameter. I'm going to execute the append, and notice what happened. This string IAmAList got appended to the default list. And remember that this default list is going to retain its value in between function calls. So even after I return from this function, I still have this value stored inside my default list. And if I call the function twice, you're going to see that I just keep accumulating junk inside my default list. There's the result after the first call. Getting ready to call it again. I'm setting up to use the default list again. But notice the default list has some stuff in it from the first time I called the function. We're accumulating junk in our default list. And that's a result of the fact that the list is actually a part of the function definition, and it retains its value in between function calls. So anything I do to change that list will be reflected in the next usage of that list, the next time I call the function. And that's really all I want to say about this. So default parameters can be very useful. They can simplify your code, but at the same time, they can introduce obscure bugs into your program if you don't really understand what's happening when you call your function. So be careful, especially if you're using a mutable object like a list or a dictionary as your default object. If you're referencing that default inside your function, anything you do to it is going to be retained. And so that's really all I had to say about this subject. I hope you learned something. I hope you have a better understanding of how variables work in Python and how objects are passed into functions, and what happens if you end up using a default value. And that's it. I hope you enjoyed the video.